Hello, welcome to Berkshire Guitar Amplifier Repairs. Stuart Smith with you as always. Now on the bench today is a Blackstar HT5. I'm going to have a go at fixing it, although I'm not hopeful. I've fixed a lot of these in the past, but I've done it by changing the board on the amp, and Blackstar used to sell the boards for these amps and the HT1 for a very reasonable price, about £35–37, so it made no sense to try and fix the amps because they're all surface mount and very hard to fix. So I would just swap the board and that would get the amp going. But they are no longer selling any of those boards. Apparently they stopped making these amps 10 years ago, according to a chap I spoke to down at Blackstar, and they've run out of boards. So I don't know why they didn't get another batch and sold them at a decent profit. You know, people would easily pay £100–150 for a replacement board. I would have thought that was a highly profitable little number, but apparently not. So up until this amp came in here, I've said to people, look, I'm sorry, unless it's something very easy, I can't fix these amps anymore. But I thought I would have a go at this one, just because, to be honest with you, I just fancy having a go at it, and the customer's a little bit desperate for the amp. So no hopes, no definite fix on this. I'll keep the video up even if I don't fix it, because I'm going to go through a diagnostic process which will at least allow us to determine where the fault lies, even if we can't fix it. But let's give it a go and see how we get on. I should have said on the intro what the fault was on this amp, and the fault is very low level output. So I've got a quite large signal going into it from my signal generator, where I've got 50–60 millivolts, which is quite high. I have the amp connected up to a speaker, and I don't know if you can hear that faint clean up full look. Very, very low level signal. You can probably hear it as I turn the frequency. Turn the reverb down. Absolutely tiny signal, nothing there at all. So let's start the diagnostic process on this to see if we can work out, well, let's try and work out whether it's the preamp or the power amp for a start off. To do that, I'm going to take the chassis out of the amp, which is very simple on this amplifier. Right, we'll turn it off, unplug it, and you don't really need me to show you this, but 4 screws here, just take those out. 1, 2, 3, 4, and now the amp will just, we have to take the back off as well, I'd forgotten about that. The 4 screws here. There we go, and now the chassis will just lift. I wish all amps were this easy to get apart. So that's an absolute doddle, that, getting that out of there. So let's get it up on the bench, and then we'll get the overhead cam up and I'll show you what I'm going to do. Well, the obvious thing to check on this amp are the 2 valves. It would be crazy if it were just a valve problem and we got more involved without even trying, ouch, hot that 12 BH7, without even trying the valves. So I'm going to swap the 2 valves with some new ones. This takes a 12 BH7 in the power amp valve. Don't forget it's only a few watts this amp, so it doesn't need much. And then a standard ECC83 in the preamp side. So I'm just going to change them both. No point in messing around one at a time. Just change them both and see if we have a valve problem or not. It's very hot, that 12BH7, surprisingly hot actually. Right, I've just waited for that to cool down a bit and it is now a bit cooler. So we'll take that out, pop in a new one and turn on again and see if that has made any difference. I'm not terribly optimistic, but I have known the valves to go on these. So we'll turn it on again, wait for it to warm up. There we go. It's exactly the same. I expect you can hear that faint tone in the background. That's with everything up pretty much full. If I turn it down to medium, you can't hear anything. So it's not the valve, so we'll turn off again. Replace the original valves and push on with the diagnosis. Right, now the next thing to do is, if you have a look at the back of this, you will see that it has an effects loop, an effects send and return loop. A common problem with amps at a low level is there is dirt on the effects send and return jacks, causing a break in the signal path from preamp to power amp. So to check that on any power amp, just literally jack out these two sockets. So put a jack socket to jack socket, sorry, a jack plug to jack plug in there, and bypass that loop. Well, we've got a handy jack plug to jack plug here, which the customer happened to supply. So we'll just jack out the loop like that, and that gets rid of any issues with the sockets themselves. We'll turn it on again and see if we get any joy. Warming up. Oh, I've taken, I haven't put the 12BH7 back in. I'll just pop that back in. There we go. Warming up. No change whatsoever, still a very low signal, so it's not that effects jack. Okay, the next thing to do is to check, is it the preamp side or is it the power amp side? Now fortunately, any amplifier with an effects loop, you can plug into the effects return and that goes straight into the power amp, and you can inject straight into the power amp with the effects return there, and that will bypass the preamp. So I'm going to take the plug out of the guitar input and plug it straight into here. There's absolutely nothing there. Obviously we'd expect a higher level signal here, so let's turn this up a bit. Okay, so I don't know if you can hear, we've got exactly the same low level signal going straight into the effects loop, and so it's looking to me like the power amp side of things. Right, so let's turn the amp upside down and have a look. Actually, a little mistake there. I believe this amplifier requires a jack plug into the guitar input to unlock the output. So we're going to go back into the effects return. We're going to turn on. Okay, we're on. I'm not 100% sure about that, but anyway, I'm just going to. I've been caught out like that before on an amplifier that requires a input jack before it'll unmute the output. That's the word I'm looking for. So I can hear that. I can hear that very faintly now. So I'm just going to plug a jack into the input. And that doesn't seem to have made any difference. So not sure about that. Okay, fine. Anyway, at least we verified that now. So let's get the amp upside down and have a look from the top. Now, if you haven't seen inside one of these before, you will see why we have a problem here and why these are exceptionally difficult to repair. In fact, it's virtually impossible if the issue is with one of the surface mount components. So you can see we have all these dual op amps here, all surface mount, all surface mount resistors and capacitors. I don't have the ability to change these. It's highly specialised work and requires a ton of quite expensive equipment. I mean, if my life depended on it, I could lift that chip there and replace it. I have done so, but I don't really enjoy it without the right kit. So we are in a bit of trouble here. But what we can do is, I think, for example, it would be useful to measure some HT voltages around this 12BH7. So do we have any high voltage here? If we've got no high voltage there, then of course, so we're just not going to get anything. So that would be my next port of call. So I'm going to plug it in, turn it on. Keep using the wrong plug here because there's a loose one on the bench. Right, there we go, plug in. It's already on. I'm not going to bother with the signal. Instead, I can't remember the pin outs of a 12BH7, but it doesn't matter because we're just going to go around the pins, and one of the probes on ground, DC, a couple of hundred volts, and if we've got no HT around here, then that would be an obvious reason. Well, we've got HT immediately. Look, we've got, cracky, 460 volts. That's extraordinary. That is flipping high. Amazing. 463. All these voltages look fine to me. Yeah. So if we only had like 20 volts or something around here, the immediate we would suspect the power supply side, but we've got 400 volts plus there. So that's all looking good. So now, what's next that we can do? Right, I've looked back through the years and I've repaired several of these amps, and a common fault with them, in fact on almost every amp I've managed to successfully repair, it has been these two FETs here. Apparently there's a well-known issue with these amps. So I'm going to replace those two on spec rather than spend a lot more time in diagnosis. It'll take me about maybe half an hour to replace them, and because I've seen that fault at least 6 times before, we've got a good chance of that fixing it. May or may not, but that's all we can do. So you cannot get these FETs anymore. They are obsolete, and so they need to be replaced with these, which are P for Peter 5 November Kilo 50 Zulu Foxtrot Papa. I'll say that again in case you're desperate to know. Papa 5 November Kilo 50 Zulu Foxtrot Papa. And they are a good replacement for the existing FETs, which you can't get anymore. Now I won't bore you with the strip down. Obviously all the knobs have to come off, all the nuts have to come off, undo the screws. Look, 1, 2, 3, 4, 5, I think that's probably 6, that's probably it. And we'll make a note of these windings here and just literally pull them all off. This unplugs at this end, and then we can take the board out. So let me push on with that, and I'll come back to you when that's done. Of course we have to take the valves out as well. That stops the board coming out. And there's another connector here. So let's push on with that. I'll time it and let you know how long it took me to get the board out. It's exactly 5 o'clock now. Oh well, that wasn't too bad. 7 minutes. And you'll notice I don't have to take off all of these connectors here. The board will just turn upside down like so. Here are the FETs here, 1 to 3, 1 to 3. I'm going to just measure these two resistors here. I don't think that will be an issue. I'll just quickly measure those. I mean, they're 22k. I'd be surprised if they're open circuit or anything. Oh, that's 20k across that one. By the way, whilst I'm doing this, these FETs sit in the tail of the 12BH7, and they are used to, I think they're used to phase split somehow. I haven't really carefully looked at the circuit. It's one of these clever, very complicated circuits, and I tend not to look at things just for the fun of it, if you know what I mean. I'm pretty busy. I don't really have time to dig out a schematic and just spend hours poring over it for my interest to see how it works. I do it on a need-to-know basis, so if I can't get an amp working, I will. It's quite unusual for me to take the schematic out actually and have a look at it. I don't often need it, just occasionally I do. Most repairs you can do without a schematic. Right, I'm just going to put the voltmeter on quite low volts, like 2 volts, and just have a measure around here. We've got like 0.1 there. I've got 16 volts there, so that's no good, that. Have that voltage floating around. It is kind of coming down. All these capacitors just need discharging, but it's not particularly easy to do, especially as you don't know where they are, and you can't get on them very easily. I mean, I suppose I could get on the bottom of these caps here. This is where the HT side of things is done. Right, let's see if we've got any voltage on those caps. I'm sorry, not bothering to show you the voltage, but I'll just shout out if I get anything. Nothing on there, nothing on there, nothing on there, nothing on there. That's a bit more like it. What have we got here? Nothing there. 4 volts there still, it's annoying. Can't seem to get rid of that 4 volts on there. Anyway, let's see if that has now improved our resistance reading on this resistor here. So this was a good one, I think, wasn't it? 22k, look, that's okay, and this was the weird one. 28k. So that's looking a bit more like it now. We've got rid of all that strange voltage. It's quite unusual for a resistor like that to go. So I think what I'm going to do is on spec. Actually, one thing I'm going to quickly do is just check that neither of these electrolytics here are short circuit. This one and this one. And quick look there. Seems all right. Seems okay. So they're not short or anything like that. Right. Well, as I say, I have replaced these FETs several times in the past, and so it would be silly of me not to just bung in a couple. It's only going to take me 15-20 minutes. Now, if this doesn't do the trick, I'm getting close to calling it a day on the amp, because I don't have that many more tricks up my sleeve on this one. Just remember those steps are on the inside. Get the FETs the right way around when I put them in. Right, so to do that I'm just going to use some solder wick. I prefer solder wick nowadays. I used to use a desoldering machine, but I just use this chem wick now. It's got resin impregnated, so don't try and use one without resin impregnated. You can just get bare braid. It's absolutely useless. They're not particularly easy to get these out, I seem to remember. Obviously have to be very careful with these very fine tracks as well. You can find that you've broken a track quite easily. This doesn't want to play ball with me today, this. Another little trick I've got up my sleeve is to take a heat gun and just warm up those pads there. and what that does is just stops all the heat being conducted away the second you get a soldering iron on it. That seems to be a little bit better. I say not easy this. If you haven't done this before, I don't recommend this as your first job. Right, is that enough to get that out? Let's have a look. Ouch! Oh, that's hot. Yep, so that one's out. I think I'll put the new one in just to allow me really to remember which way round it goes. Okay, there's the new one. I'm just going to leave it there. I will remember, of course, but it's just surprising how you can fool yourself. I only need to get a phone call or something. I've taken both FETs out. I go and have a phone call, come back, and I think, which way was it again? Anyone who repairs things who's watching this will know exactly what I'm talking about. Right, so let's see if we can repeat the process on this FET. See, I seem to remember these FETs get pretty hot when they're working normally, and you know, Blackstar haven't put a heatsink on there, which is not very good, is it? I don't think. You've got two very hot FETs there. You're just getting ridiculously hot, no heatsink, and they fail. I'm putting quite a lot of pressure on the soldering iron here. I'm not just dabbing it on, I'm really pressing hard and waggling a little bit too. And now if you use the soldering iron, you can just sometimes just move the pin a bit, which kind of proves it's free. There. So again, with a bit of luck, that might come out. Just say ah, this won't hurt a bit. Ah, there we go. Ouch! Oh, that's bloody hot though. Right, pop the other one in. And there we are. So we have our two new FETs in there. And we can solder those in. It doesn't take too long to replace these. It's interesting when you repair things, there's a kind of trade-off really between endless diagnosis, putting a scope on, tracing signal through, getting the schematic out, and then just thinking, you know what, I'm just going to change all the valves, and now I'm going to change this. It works like 75% of the time. Other times you do have to get quite clever with it. There we go. Right, so that's the new FETs in. We don't have to bother chopping off the legs. There's miles of room between there and the board. Right, whilst we're here, I am just going to quickly measure those resistors again, because they are in that circuit there. So it takes a lot for a 22k resistor to go. Possible. 200k there. And we should have lost a bit more voltage by now. So this one is 22k, look, and this one is 23k. I'm happy that those resistors are okay. So I think we've done all we can there. I can't get involved in surface mount stuff or little chip resistors or anything like that. It's either going to be something big and obvious, or we chuck it in the bin. I don't even think Blackstar would fix this at a component level. So let's pop it back in. We're not going to do any more to it anyway, so I think I might just put all the pot nuts back on. Let me think. Yeah, I'm not doing any more to this amp. If that hasn't done it, forget it. So I'm going to put the amp back together and then we'll try it. Okay, bad news, that hasn't made any difference whatsoever. So that's a shame that. Both of these are getting warm, so that means current's going through them. There's 100 volts across each of those 22k resistors, which means current's going through them, and they're not open circuit or anything. So I have no idea what's wrong. I'm going to call it a day on that, and I will publish this video just because you might find it interesting, even if you're, not, even if you were hoping for a fix and I didn't provide one. I'll probably give Blackstar a call. There's a friendly engineer there I've been dealing with, and I'll tell him the voltages and stuff I'm getting, see if he has anything more to say to point me in the right direction. Right, I thought of one more thing I can do, and that's to check the signal on pin 1 and pin 6 of the 12BH7. Those are the anodes, in other words the outputs of that valve. So if we've got a nice big signal on there, that's pretty much connected to the output transformer, and so that would tell us that the signal's at least getting to here. So if I go on to pin 1, look there, and I look at the scope, you'll see I have quite a big signal there. It's like 5 volts, 10 volts peak to peak, and there's a lot of hum on it. That's what that bouncing around is. I'm not quite sure what the hum's about, but we've got quite a big signal there. Okay, let's now go back onto pin 6, which of course is the other half of the split phase signal, push-pull signal, pin 6, look there. And again we'll go over and we've got the same thing there. So it's looking like that valve was putting out a decent output. I haven't got the signal generator turned up full, so that would put out a bigger output than that. So the signal's getting all the way to the output transformer. Now what I think I'd like to do now is to measure the actual output signal coming out of here. We know it's small because we can hardly hear anything, but let's just see how big or how small that actually is. Well, there we go. The answer is 20 millivolts. Absolutely nothing. So I'm wondering if the output transformer is faulty. That would account for that. We've got a fairly decent... That's interesting. Not quite sure why that's doing that. Oh dear. There's a huge hum there. Not quite sure what's happening there. I think I'll just turn the amp off, because if the output transformer is faulty, who knows what kind of load that's putting on the for example, if the secondary is short circuit or something, that would be putting quite a big load on the valve. So what I'm going to do is disconnect. I think I will disconnect the output transformer from the back board here and put a scope on there again, just in case there's something funny going on with the back board here and there's a short circuit there. I can't really imagine there is, but let's do that. And if that's the case, I think it's time to suspect the output transformer. Okay, not quite sure what I'm looking at here, but this is on the output with no speaker connected, so I've just disconnected the... It's just hanging on the secondary of the output transformer. You can see the signal there, that's that high frequency part of it, and it's got this huge hum on it. So if I expand the trace, you can see there's our signal there, but there's got this huge 50 Hertz hum all over it. Not quite sure what's going on there, but anyway, it's a little bit bigger. It's 1.5 volts or something, so that's without any kind of load. I think I'll just clip my loudspeaker onto that and see what happens then. Okay, here's a little output transformer from a Fender Blues Junior. It won't in any way match this amp at all, of course, but it'll vaguely work. And it's a bit of a lash up this, so I've got crop clips going from all the connections on this up to the actual amp itself. So look, I've crop clipped onto the primary of the thing that feeds the primary of the transformer, and I've crop clipped onto my external speaker here. It goes off to my bench speaker. So basically this is now substituting for the existing transformer. So if we get any kind of signal here, it's going to prove, I think, that the output transformers may be faulty. Okay, we're all connected up. I'm just looking at my connections here because these have got several hundred volts DC on them, so we want to be very careful. Just looking down at my bench and they're all clear. I'm going to turn on the amp. We're plugged in with a signal, guitar level signal. So let's see if we hear anything. Take a minute or so to warm up. Ah, interesting. Yep. That's perfectly okay. Let's just plug the guitar in. How about that? Oh, well, I'm actually very, very pleased about that. That means that unusually I've never replaced an output transformer on one of these. That means that it's the actual output transformer which has failed. And that can be found. I mean, it's only a 5-watt amp, so it doesn't need much of a transformer. And there it is there. That little beastie there. So I will need to get onto Blackstar, see if they can supply me with one of those, and I'm delighted to say that we will have fixed this amp, which is a real result. I mean, obviously I replaced those FETs when I didn't need to, but all you can do when you're repairing stuff is to have a hypothesis and see it through. And at the end of the day you might think, oh, well, I wish I'd checked the output transformer first, or whatever, you know, and maybe I should have, but that's all you can do. Follow a hypothesis, and then if that doesn't work, try the next thing, and then try the next thing. That's all we do, we technicians. So it's a Blackstar 59Y238, God knows. I've got the number for Blackstar spares, so I'll give them a call on Monday and see if we can get one, and then we'll drop one in and hopefully we'll be good to go. Nice one. Right, well, welcome back. It's been a few days for me and just a few seconds for you, but I have now the replacement output transformer from Blackstar. Fairly expensive. It cost me £75 by the time I got it, so you know, it's going to be a fairly expensive repair. Anyway, the first thing I've done is to put a green dot on it there, and I've also put a red dot on the faulty one. Very easy to get mixed up when you're doing this kind of job, and you end up with both transformers on the bench. You think, oh no, which is the new one? So all these things come from experience. So I'm just going to take this, see what's involved in taking this transformer out. Oh, they've made that quite easy because they've got some retaining nuts in there. Probably won't bore you with doing this because all I'm going to do is take this transformer out and put this one back in, so I won't waste your time on that. I'll do that quickly and then we'll see if it works. I hope it does. Okay, there's the new output transformer in. Whilst it was out, I measured the windings on both transformers. I couldn't really see much difference between them. It wasn't as though this was short circuit or anything and this was 20 ohms or whatever. They both measured kind of the same, so whether this is breaking down inside, I don't really know what's going on, so can't really enlighten you on that. But anyway, the new transformer is in. We are turned on. Are we on? Yep, we've got a guitar plugged in, so I can immediately tell it's working. Job done. Amazingly, that seems to be working okay. The reverb is quite good. That was only on about 3, that reverb. Digital reverb, of course, on this. And overdrive. Yep, that's all okay. So that was the problem. The output transformer, not quite sure what's wrong with it, but that was the issue. Right, let's get it back in its case and I'll wrap up the video. Okay, well, I hope you enjoyed that one. These amps are not particularly easy to fix because of all the surface mount stuff on them, but they normally have a handful of problems which, I don't know, 75% or more of amps you could fix. So those two FETs that I changed, they're a kind of go-to immediately. And then you need to have a look. Well, I had that output transformer problem, but that was the first Blackstar that I've had with a failed output transformer, so it might not be that common. But I think what you might have found useful in the video was the diagnostic process. So just kind of go through it stage by stage, put a signal into the effects return. Is the power amp working? If not, then it's a power amp problem. Obviously change the valves. I've had valves go, so that's the number one thing to do. Check the HT, and maybe before changing those FETs I should have put the scope on the output there and the input to the output transformer. I might have saved myself the bother of changing those FETs, but of course, having changed loads of them in the past, I thought, oh, I know what this is, it's the FETs. So anyway, it only took me 20 minutes, so that's fine. So the customer will be very happy. Bit of a bill for him, I'm afraid, you know. I think I'm going to charge him something like 125 quid, which is not a lot really, it's 50 quid plus the transformer, but that's still getting up there considering what the amp's actually worth. And it's a shame that Blackstar stopped selling those boards because they were like 35 quid each, and you could just cure a problem by swapping a board out. So you could fix an amp every time for £75 or something, so that's a pity, but anyway. Okay, well, hey ho, there you go. That's another one in the pot, and as I record this, I've just passed 1 million views on my channel, which is absolutely really amazing. Since I started it from absolute scratch with no marketing of any description whatsoever, I just started it and put up my first video, got my first view about I don't know how long ago now, 4 years ago, and I've got 1 million views, which is great stuff. Anyway, thanks to you for watching and being one of the million, and I'll catch you on the next video.